Hello, here's the question number 22. That says a coil is wound on a hollow insulating cylinder which contains in it a laminated iron core. How the inductance L of the coil varies with the displacement X of the core as is shown in this figure. In the initial state when X equal to 0, that means the core is fully inserted into the coil, the current in the coil is measured as 1.0 ampere. Find the current in the coil immediately after the core is quickly taken out of the coil. So there's a coil, and inside that there's a core, and then based on the position of the core, the inductance varies like this. That means when it is completely inside, so inductance is like this number. Now you can measure like this is 1, 2, 3, 4, 5, 6. So that's 5 unit. Then it decreases to 4, then 3, then 2, then 1, and then later on remains 1. 1 is a constant one, right? Now since this is quickly taken outside, so in any coil, if we make any quick change, something does not change, that's flux passing through it. So due to sudden removal of the core, the flux through the coil will not change. That's the property of inductors. Now flux will not change. So whatever the initial flux was, that same remain at the final. So final flux must be equal to initial flux. Now in the coil, how much the flux will be passing through, that will depend on L into I. So L into I final must be equal to L into I initial. Now final L is a constant which is at one value from the figure. I is final, that is we need to find out. L initially was this, because X equal to 0, it was completely inside, which is 5 from the figure. I initially has been given as 1. So from here, this I turn out to be 5 ampere. That means this is the current which will be finally, we will observe, that means this current will be just after the removal of the core. So this will become our final response. Thank you.